Okay, so once we did loading the data and dividing it into test and training, now it's time to define the model. So let's go to this ML diabetes prediction and double click on train model. And as I mentioned, we will be using ANN for this particular project. So let me write a try catch first exception and message box ex.message. And we need to make sure our data test train data is ready. So x underscore train, if this equals null, or y underscore train equals null, then we can throw a new exception here that no data is found for training, for example. Y underscore train. Okay, if we have data, then we can proceed with the training. And instead of writing here, it would be better to create a different method. So public void apply ANN, for example. So we can parameterize this method as the artificial neural network requires some parameters, and we need to find actually the optimal values of it. But in this tutorial, we will be using some random values. So I'm going to set those values as a parameter. The first thing that we need to do is ANN MLP dot activation function. So which activation function we are going to use? I just MLP activation function or something like this. And the default, I'm going to use an MLP dot, let's say, sigmoid function. The second parameter here I want to use is, let me make it like this, the training method, or for the optimization method that we are going to use. And we can just select one of these train method. I call it train method. And this one I want to initialize or give a default value of, let's say, backpropagation. And another parameter that is important is the momentum. And let's set this value to be 0.00 or 0.1 or whatever you want. And another parameter that we need is iterations. How many iterations? Let's say we want 500 initially. And the minimum root mean squared error that we are expecting is 0.001. And another value that, for example, if you want to save the model and should we retrain the model, we can specify it here from this bool save load saved model. It means if we have already trained a model and if we want to load it, and then initialize it to the false, so that whenever I will call this method, by default it will use these parameters. Okay, and then I will be using try catch, and if we have an exception we can throw that new exception ex.message, for example. So first we need to know the number of classes that we have, so we can write a simple method to get the number of classes from the training labels, I mean by counting the labels. So let me write that function as well. First of all, to get the class labels or the class count, let's go and add another method. So I'm writing public static. It will give us an integer number of classes based on our labels. So get class count, and we will be giving a matrix as input of type integers, and let's say y underscore labels. And we can also do something like this: throw new exception ex.message. Okay, so I want to find which are the distinct label values. So let me create a variable called labels is equal to new integer. So I'm going to create an integer array labels.rows, and then I can copy while labels.mate.copy to labels. Okay, this way just I copy my matrix into labels, and then I can use this function labels dot distinct dot count. So it will give me the distinct values of the classes. Another thing that we also need, let me write this here, is the hot matrix or one hot vector representation. What does it mean is if we have two classes, for example, in our case 0 and 1, 0 indicates the diabetes non-diabetes patient, and 1 basically represents the diabetes patient. So for this one we can represent this one instead of with 0 and 1, we should represent it with two values. 0 1 is for class 0 and 1 will be represented as 0 1, for example. So the output neuron will have these two neurons, our output layer will have these two neurons. If one is outputting 1 and another one is outputting 0, it means that we are talking about the class 0. So this is what we want, one hot vector representation. So we also need, when we are using the neural net, so to convert our labels into one hot representation, hot vector representation, I'm writing this method. So public static, it will be returning a matrix of integers as well, and I call it hot matrix. And for this one we will be considering the mate, the input label, so I call it y underscore label, and also we should know the class count, how many classes we have. So let me create another matrix for hot vectors. The vector is equal to new matrix. It's basically another matrix, and what should be its size is the same as the number of rows in our label dot rows, but the number of columns should be equal to the class count. Okay, so and now we can set to make sure that all these values are equal to 0. So I'm using set 0. Just initialize. By default integer should be initialized with 0, but to make sure. And now for, let me run a loop through the all rows in my y label.rows. So I'm going through all the samples or all the labels, and then I'm setting the hot vector for this row should be same as y underscore labels row comma 0, and this one should be equal to 1. This is very important to understand that we are given a label, like for example y underscore labels and then class count. Let's say we have received 0. So this one will return us a 0 for us. For example, if we are at 0, so for the first sample, 0, 0 will be equal to 1. So the representation will be like, to represent the class 0, we will be doing 1, 0. We are not setting the other value. And if we are receiving a 1, so this one will be returning us a 1. It means 0, 1 is equal to 1. It means the next value will be 0, and the rest will be set to 0, and only one value will be changed. So this way, but one thing you should remember, that the classes should be, if you have more than one class or more than two classes, those should be labeled like 0, 1, 2, 3, 4. If you are using -1, 0, 1 or -1, 1, then you have to change this method. And I assume that your classes are arranged this way, 0, 1, 2, 3, 4, like this. And once we do this hot vector representation, we can return the hot vector. Okay, so the hot matrix representation is also ready and our get count class is also ready. Let's go and use it here. The first thing that I need is to get the number of classes that we have in this method. So I will do like number of classes is equal to helper class dot get class count, and here we are passing this y underscore train. In the y underscore train, how many classes we have, we just need to identify. And also we need to have a hot vectors representation of the input data. So helper class dot hot matrix. And here we are again expecting the y train, and also we need to tell the number of classes that we have. So essentially this will be the same, but the representation will be different. Instead of just one label like 0, 1, we are representing it with 0, 1 and a 1, 0 in our this current case. I think I forgot to mention here is we also need to pass the number of layers that we want in our network, and also how many neurons on each layer. This is very important. So let me create an integer array and I just call it layers. And let's say initialize it with null. I mean, if nothing is sent with, then we can set it here. For example, if our layers are layers equals null, then by default I'm going to set the layer size to be, for example, layers is equal to new int. And now this is a little bit tricky. I am assuming that I have, of course, I need the input layers and the output layers. And for the input layers, we must have the same number of neurons as our input. So that input is basically defined by the number of features in our xtrain dot columns. That is the number of columns or the features. And on the hidden layer, by default, let's say I'm using 50 neurons, or let's say 20 neurons. Make it easy. And for the output neurons, it's important that we define the number of neurons to be the same as our number of classes. So the input and the output should be fixed according to our requirements, or the input and the output. And in the middle, we can have one layer, we can have 10 layers, we can many layers we want, and number of neurons can vary, we will see. But if we are not passing anything, I am setting this one as a default value. One thing, and to make sure that the number of layers, if we set the layers from outside and pass it here, then I need to make sure that those should be the same as our input features. So if layers 0 is not equal to x underscore train dot columns, then we should not proceed. So throw new exception, and we can say input neurons must be same as x underscore train dot columns. Okay, for this particular case. If this is not, we can also check for the output also. And if layers dot, this is the last layer, so I want to find out layers dot length -1, that is the last layer. And if this one is not equal to number of classes, then we must also output neurons must be number of classes. Okay, so this is just for making sure that input and output neurons are same, and the number of neurons in the middle can be, we can change them in the middle layers. or in the hidden layers. So if the layers are okay, then the neurons or the ANN in OpenCV is expecting a matrix of input layers. So I'm just going to convert into the matrix. I'm just going to create an integer. Layer size is equal to new matrix, and here we can just directly pass the layers array. Sorry, layers array. Okay, so from this layers array, I just created a matrix so that we can pass it into our ANN. So this is the time to create a ANN model now. So I'm going to create an object of ANN. So it would be better to initialize it or define the ANN object on top, because I'm going to use it throughout I will share it among the methods. So ANN underscore NLP, and I just give it a short ANN, and let me say that it is null initially. And now we can initialize it. ANN is equal to new ANN underscore NLP object. Okay, and we need to define some features that we have, or the characteristics that we need to do is the first we will define the training method. So the training method that has been sent by the trained method variable here, so we will be using whatever the trained method we are passing. And ANN dot set layer size, that is the layer size that we have already defined here. Okay, and one thing, it is, I don't know it is still exists or not. I had a problem when I defined this layer size before the training method. It was giving me error. So you should be aware that I suffered a problem like this. But now you need to first define the set trained method and then set layer size. I mean, it shouldn't be like this, but I faced it. Now I don't know whether this has been fixed or not. Okay, then we can also define a termination criteria, which means that if our training continues and if we could not reach the desired error, how long should it be? I mean, it should stop somehow. So here I'm going to define two things: the maximum number of iterations that we have. So we will define the iterations, or our error reaches this minimum error, then the training should stop. And also we can set the activation function that we want to use. So the activation function and an activation function that we are going to pass as the method. And also I will set the momentum. This is also an important backprop momentum scale. For example, we are going to set the momentum scale. Okay, I think these are the basic parameters that we need for ANN. And before passing the training data into the ANN for training, I can create an object of this train data. This is what I call it. Data is equal to new train data. And here it is expecting the samples. These samples are in x underscore train. These are our samples. And we need to tell what is the data layout. This data layout I'm going to use is the raw sample. It means that our samples or the examples are arranged in a raw format. So each row is representing one sample or one example. Okay, and lastly it is expecting the labels that we are going to pass. So the labels are present in hot vectors, and this one is expecting them in float. I mean, I don't know why it is expecting, but if I work with the integers, it is giving me error. So let me push it to the next line. So we just created a train data object. We passed the training data and also the labels by converting them into a float vector. And also we set what is the layout of our data. So, and now we can train the ANN classifier. So to train it, I will be calling this train method. And this one is expecting a train data object, which we have created. And this one is expecting the parameter the flags. We can, it is, by the way, if it is 0, it means the default value, but what this one is expecting is, for example, ANN MLP flags. These are the different options available. You can select the default, that is 0, no input scale, no output scale, update weights. So you can check the documentation here. For example, if we set it to update weights, so it will compute or update the weights instead of computing them from scratch. And if we set it to no input underscore scale, it means it will not normalize the input vectors. And if we set this one to no output scale, so it will not normalize the output vector. So I'm just using the default one, so dot default. And since this one is expecting an integer, I think I mean it is expecting to be converted into an integer. Okay, so this is the method, train method, which is going to train our ANN on this data that we have provided according to the settings that we have defined. And by the way, this one will return us a variable, just call it result. It will be bool. So this one will tell us if the model has been trained or not. And let's say that if result equals true, it means the model has been trained. So we can say label dot text is equal to model is trained. Else we can give a message lbl status dot text is equal to model could not be trained, for example, if any problem happens or if there is any error. And so this is the situation when we do the training from very scratch. But if we have already trained it and if we want to load that model, then we have said that this is load saved model. Right now it is false. So we are expecting that if this is true, then we assume that model has already been trained and we don't want to retrain it every time. So what we can do that, let me put a condition also. If this is equal to true, it means that we need to check that there is already a file or already a model that already exists. So I'm saying file dot exists. So let's see what type of file exists. And let's say that we save the model with some name, string model name is equal to ANN. So in case we want to load the existing model, then we can check if there is a file that exists, model name, and then we can use file storage. File is equal to new file storage, model name, and the flags file storage, and we will just want to mode.read. We just want to read the file. Okay, instead of writing the text here, let me do it like ann.txt. Let's say we want to write it as a text file, write the model as a text file, and then we can say ann.read file dot get node, and here we will say that opencv underscore ml underscore ann underscore ml, and then we can say lbl status dot text is equal to model loaded. Okay, so this is how we read the model. So this is the default name that is written when we write the ANN model when we use the save. So if we need to load it, the existing model, then we will be using this one. Else If we don't need to do it, rather we need to train the model from very beginning, then of course we will be doing, let me copy it and paste it here. So, and if we have already trained it, we will load the model and give a message, and otherwise we will train the model from very scratch, and we can also save it so that ann.save, we can say model name. That's it. So this will save the model, and then if you want to read the already trained model, we can do like this. And literally that's it. And what we can do here is to give flexibility, what kind of, so we can call this method. By default we can call this method like this with the default parameters, or we can pass the values, different values of the parameters.